Okay, so the first question, we have a displacement versus time graph. And the question is saying, what is the average velocity for the line? Displacement versus time, what's the slope equal to? Like in velocity. So with a d versus t graph, remember your slope is going to be equal to your velocity. So for the average velocity, for c, what we need to do is we need to find the slope of c. So remember, it's rise over run. So we go over from 1 to 9, or we can go from the origin too. So from 0 to 9, and then we go up about 3. Okay. So remember, it's rise over run. So that would be, we went up 3, and then we went over by 9. So we went up 3, we went over 9. So that means that we went. Our slope should be 0.33, about 0.33, so that's going to be my velocity. For these 3 lines, which one is moving the fastest? A. What do we know about the velocity besides the fact that they're all constant? They're all positive. So we have the positive slope equals a positive velocity. And we know that A is going to be moving the fastest because the slope is the highest, it's the steepest. So if it was going down, it would be a negative velocity, which means we're going in either the westward direction or the southward direction. Okay? All right, so now the next question. Car travels 90 meters due north in 15 seconds. It should be just the car turns around and travels 40 meters due south in 5 seconds. What is the magnitude of the average velocity? Velocity is equal to what? Displacement over time. So we need the displacement and we need the time, the change in time. What is the displacement? 50, right? We go 90 meters north and we go the opposite direction, 40 meters, which means that our total displacement should be 50 divided by our total time that's passed, which should be what?
20 seconds.
20 seconds, because it was 15 seconds and then 5 seconds. So 50 divided by 2 is going to give you a velocity of 2.5. What if it was asking for the speed? What would you do?
Add 90 over 15 plus 40 over 5.
Well, okay, what's the difference between speed and velocity?
Direction.
Direction, right? It could be. So if we are looking for the distance, what is the distance that this person went?
130.
130. Okay, there is a difference. Watch what's being said. If it's asking for the speed, the displacement will not be 50. Okay, so it would be 130 divided by 20 seconds. Okay, remember, if you're going around in a racetrack, okay, and you end up in the same spot, then your velocity ends up being 0. But if you're looking at speed, your speed is quite different. Okay, so a car increases its speed from 9.6 meters per second to 11.2 meters per second in 4 seconds. The average acceleration for the car during the 4 seconds. Well, what's acceleration equal to? Yeah, so the change in velocity divided by the change in time. So if we're looking for acceleration, what's our VF? 11.2. What's our VI?
9.6.
What is it? 9.6?
Yes.
Sorry, it's all weird. 11.2 minus 9.6 divided by my time of 4 seconds. So our acceleration should be 0.4 meters per second squared. Okay? So what does that mean, meters per second squared?
Acceleration.
Acceleration, okay, those are the units of acceleration. What does that mean? Every second, what happens?
You go up by that much.
Your velocity will go up by that much, right? Or go down. So we go up, our speed will change by 0.4 meters per second every second. All right, so let's do another couple of questions. Car traveling on a straight road. Let's go ahead and do that one. And then let's do 4, 5, and 6. give you guys a couple of minutes. Yes.
So for acceleration, when you're putting it into a formula, you don't square, right?
Mm-mm. Because what ends up happening is you have meters per second on the top, because that's from your velocity, and then you have seconds on the bottom. So you really end up squaring it because of the units themselves. Okay, so you're not doing no squaring. Yep. All right, so let's look at number 4. All right, so number 4, car traveling on a straight road, 15 meters per second, accelerates uniformly to 21 meters per second in 12 seconds. The total distance traveled by this car should be what? Okay, when you have a situation like this, you have your 5 variables. Go ahead and list those. So we know that we have VF, we have VI, we have acceleration, we have time, and then we have displacement. Okay, so what information were we given here? What was my initial velocity? 15, right? Okay, what's my final velocity? 21. All right, do I have acceleration? No. Do I have time? 12 seconds. Okay, do I have displacement? No. Okay, so I don't have time. I'm sorry, I don't have displacement. I don't have acceleration. Okay, so when I look at the equations, okay, do I have an equation where I can solve for my displacement without getting my acceleration? So if you look at your review or your reference sheet, do you have an equation that just involves solving for displacement without the use of the acceleration? No. So that means I'm going to have to do what first?
Solve it.
Get acceleration first. So I'm going to get my acceleration first. So I'm going to use which equation to do that? Which one?
Do you have the sheet top middle?
Top middle. So VF squared.
Nope.
VF equals VI.
Over T. Looking for acceleration.
Okay, yeah, so we can solve for the acceleration. So VF is going to be 21 minus my VI divided by my time of 12 seconds. And then when I get my acceleration, I should get 0.5 meters per second squared. Now can I get my displacement? Yeah, so now I'm going to use the displacement equation. So delta x is equal to, remember that equation? It says delta x is equal to the initial velocity multiplied by the time plus 1/2 AT squared. So VI is going to be 15 here. My time was 12 plus my 1/2 multiplied by my acceleration, which I just found, okay? And then my time squared, which would be 12 seconds squared. So you should get 216 meters for this. So some of the problems, go ahead, pull out your 5 variables, okay? Remember, you do have simple equations too. So if it's just asking for acceleration, do you have VF, VI, time? If it's looking for velocity, do you have the displacement and the time? But if you have those 5 variables, look through your equations, okay? Is there one equation where we can just do one? Or do we have to find the other variable first? Okay, so you should get 216 for that one. So a car increases its speed. So I'm not really going to do much with it in the way of this. This is acceleration. So VF minus VI divided by my time. So that's going to be VF was 15. So 15 minus my initial divided by my time of 3 seconds. And you should get 1 meter per second squared. What is the speed of a 1.5 kilogram mass after it has fallen freely from rest through a distance of 10 meters? Okay, does the mass matter? No. So it's extra information. You're not doing anything with it. Because remember, mass does not impact acceleration. Doesn't impact how fast it falls. So when we look at the information we're given, okay, so VF, VI, acceleration, time, displacement. Okay, what do I know in this problem? Okay, the initial velocity is what? 0. If you're dropping something, your initial velocity is 0. Final velocity will be 0 when you get to a maximum height. Okay, acceleration should be what? Negative 9.8 meters per second squared. What's my time? I don't know. Okay. What else do I know? 10 meters, but it should be what? Negative. If we're falling down, the displacement's going to be negative. Okay, so I also don't know my final velocity. Okay, so when I'm looking at this, is there an equation I can use to find final velocity without finding the time? Yeah, so we have an equation, it's VF squared. So we have VF squared is equal to VI squared plus 2 times the acceleration multiplied by my displacement. All right, so now VI is 0, 2 times my acceleration times this, negative 10. All right, so then you're going to get 196. That's equal to VF squared. What do you need to do? Square root it. So you're going to take the square root here and here, and then you're going to get, what was the answer for that one? 6A. So 14. Can you take the square root of a negative number? No, so that means you forgot a negative sign. Same thing if you get negative time. Something is wrong. You've missed a negative sign somewhere if you've done that. Okay, so let's do the next 3 problems. Yep. Mm-hmm. Well, hold on. Give me a minute. Yeah. Should be 100. Okay, so are we ready to go through these? Okay, so train accelerates from rest with an acceleration of 4 meters per second squared for a time of 20 seconds. What is the train speed at the end of 20 seconds? Okay, so 5 variables. What are our 5 variables? And then delta x. Okay, what is our final velocity here? Do we know the final velocity? No. Okay. What's our initial? 0. Can you grab that? Acceleration. All right. Time. 20 seconds. Okay. We also do not know displacement. Okay, so we know the acceleration, we know the time, we are looking for the final velocity. What can I use to solve?
VI plus AT.
Yeah, so I can solve for my VF.
You meditate.
So I'm looking for my final velocity. My initial velocity is 0, my acceleration is 4, and then my time is going to be 20. So that should just be a final velocity of 80. So you should get 80 for that one. All right, so a ball is thrown down a cliff. What is the acceleration after 10 seconds after falling? Don't pick up a calculator. What should that be?
Negative
9 point, okay, so it should be negative 9.8 meters per second. There are no negative answers here, so you don't need to worry about that. Now, if it had a positive answer and then a negative answer, which one would be more correct?
Negative.
Negative, okay. Bicyclist moves from rest to a speed of 4 meters per second. How far will the car move after 5 seconds? There is a typo in the answers here. So, what do you have to solve for first here? Acceleration. Okay, so you have initial velocity of what? 0. Final velocity of? 4 meters per second. And then we have a time of 5 seconds. So acceleration is equal to the change in velocity over time. So we can do final velocity, which is 4 minus 0 divided by 5. So that gives me what? That's 0.8. 0.8 meters per second squared. All right, so then what I need to do is I need to solve for my displacement. So I can use the delta x, I'm going to just write over here, is equal to the final or initial velocity times time plus 1/2 acceleration times the time squared. So my VI was 0. So I can just get rid of that altogether. So it's 1/2 multiplied by my acceleration, which I just found, which was 0.8. That's not 8. Multiplied by my time, which was 5 seconds, so 5 squared. So I'm going to get 100. That should be 100 here. Okay? All right, so now let's move on to some graphing stuff. Yeah, okay, so I know, I see the typos, it's fine. Typos happen. All right, so which of the following statements is true? Refer to the graph above. Okay, the velocity of the object is negative. Is that true? No, it's positive for both segments. The lines on the velocity versus time graph should be curved. No, they should be what? Horizontal lines, right? Because look, I have a constant velocity here. I have a constant velocity here. So on the V versus T graph, I'm going to get horizontal lines that go like this, right? Okay. The lines on a velocity versus time graph should be horizontal. Okay, so that's true. The object's velocity is constant throughout the entire time interval. Is that true? No, right? I slowed down at this point. So I started slowing down. Okay, so the next question. An object moves at a constant speed of 6 meters per second. This means that the object does what?
Move 6 meters every second.
Yeah, moves 6 meters every second. Okay, we're not talking about acceleration. Acceleration would be, I would, if I had 6 meters per second squared, the velocity would change by 6 meters per second every second. All right, so this one right here, which of the following statements is true regarding the position versus time graph? Okay, the object increases its velocity. Is that true?
No.
Okay,
No, it's not true.
what do we know about this slope? Because this is a distance versus time graph.
Negative.
Okay, it's negative. What else?
Negative.
It's
Constant.
linear. It's constant. So that means that the velocity should be
Same.
the same. 1 meter per second, 1 meter per second, 1 meter per second. What do we know about the direction?
Negative to west.
Going westward. Okay, also, it does not start at 0, which means that this object, whatever this is 10 meters away from the frame of reference. Maybe we're 10 meters east of my origin, okay? So remember, we have to refer to the frame of reference, whatever we've decided. So maybe it's my house, maybe it's the school. The object's velocity is constant. Well, that's true. Okay. If the velocity is constant, what do we know about the acceleration? There is no acceleration. So in A versus T graph, what should I see? 0. All right, the next question. Which of the following statements is not true regarding the velocity versus time graph? Okay, the velocity in the third line is negative. Is that true? The third line meaning from 6 to 10 seconds. Right. Remember, we're looking at a velocity versus time graph, right? Okay, so a distance versus time graph, if we had a negative slope, that would mean it was a negative velocity, right? Watch the axes. Watch what you're looking at. Okay, so the velocity is not negative until it does what? Crosses the x-axis. So we don't have a negative velocity yet. All of them are positive. Okay, the acceleration is 0 at the second line. Well, let's see. 4 meters per second. 4 meters per second. 4 meters per second. Is that true?
Yeah.
Yeah, there is no acceleration in that second segment. The acceleration of line 1 is positive. Well, okay, what is the slope equal to on a velocity versus time graph? Acceleration, right? So that means right here, do I have a positive slope? Yeah, so I have a positive acceleration. All right, what do I know about my acceleration here? Negative. Okay, so I'm slowing down at that point. All right, oh, the acceleration on line 3 is negative. Yes, that's true. Okay, so right here I'm going to have a negative velocity or negative acceleration, which means I'm slowing down.
So the answer is
D,
D.
yes. All right, so this one, what is the acceleration from 6 to 10 seconds? How do I get that? The slope, okay? So, from 6 to 10 seconds, how far does it go down?
Maybe 4.
4. It goes down by 4, so it's going to be negative 4. And then also, how many seconds do we go over? 4. So it's negative 4 divided by 4. That should be an acceleration of what? Negative 1 meter per second squared. So every second I slow down by 1 meter per second. Okay, so let's just talk about a few things because your test is tomorrow. Okay? Okay, let's talk about direction again. Okay. When we go east or when we go north, what do we know about our velocity? It's positive. Okay. So in the positive direction, acceleration makes sense. So if I'm going in the positive direction and I'm speeding up, what do I know about my acceleration? It's positive, okay? If I'm slowing down, what is my acceleration? Negative, right? When I go in the negative direction, so if I go to California, I go west, I go south, okay, everything gets flipped. So if I am going westward, my velocity is negative, or I'm going south. That means that when I'm speeding up, now my acceleration is actually negative, okay? And then my acceleration when I'm slowing down will be positive. Nothing makes sense going to California, okay? So also, let's put it in terms of like direction. Okay, so we know when we have a positive acceleration with a positive velocity, I'm speeding up. So let's say that I'm going northward, okay? I'm going northward and I'm speeding up. If I give my acceleration an actual direction, it would be north, okay? Okay, let's say that I'm going east. So I'm going east and I'm speeding up. My acceleration would also be in the east direction. What if I'm slowing down though? What do you think would happen? It would be negative acceleration. So that would actually be, if I'm looking at just directions instead of positive or negative signs, okay? It would be what? West. It would be the opposite direction, okay? So if the signs flip, the directions flip. Does that make sense? Okay. All right. Trying to think of anything else I want to talk about really quick. Thank you, Marcus. I'm sorry. All right. Does anybody have any final questions before we go? Acceleration, if we're using gravity, should always be what?
Negative 9.
Negative 9.8. Okay, if I'm moving in the upward direction, what do I know about my velocity?
Positive.
Positive. If I'm moving in the downward direction, what is my velocity? Negative, okay? If my maximum height, what is my velocity? 0. Okay, but acceleration is always going to be negative 9.8. All right. Any other things that you guys want to ask me? Speak now, forever hold your peace. Yes.
I feel like you already said this, but so wait, acceleration during like even going up, just
Yeah, so if I'm going up, my velocity is positive, right? Okay. But I'm slowing down. So as I go up, I'm going to slow down, which means my acceleration should be negative.
So it's still negative.
It's still negative 9.8. And then when I flip the direction, it doesn't make sense, so it's going to be negative still. Yep.
It's kind of going off my questions as the other. I understand why it would be negative 9.8 if you're throwing up, but like why would it be negative 9.8 if it's going down?
Okay, so we're falling down. What do I know about velocity?
Negative.
It's negative, okay? When we go in the negative direction, nothing makes sense, everything gets flipped, okay? So then our acceleration ends up also being negative. So that's why you can always say it's always going to be negative 9.8 no matter what, okay? Please study. Work on the practice problems, check your answers.
So those are due tomorrow, all of the practice work?
Okay, how about this? I'm going to have you guys turn it in, okay, for like a 10-point formative. If you don't turn it in, I'll just use your test score. That's what I'll use. So it's kind of optional, but, you know, if you just want a free 10 points, no matter what, like, do it. You actually, you know, show me the work. And there you go, okay? Yes, can you guys pass that over?